Right, this is third part of the video. I just continue from previous one. I made a selection for the edges. You can see right now the edge is 1. I can do the same thing to detach the component. So after you do it, if you select the face and move up a little bit, you can see the edge is actually being split into 2 edges. So you actually get openings right here. Now let's convert this into unclass and see if the behavior is different. Keep in mind this will be done, should be done before you run the unclass simulation. So convert to unclass, then pick up the points, and then I will constrain the points, and I will play the simulation. So you should be able to see all the openings right here. So that will kind of confirm it does affect how the geometry behave, and it should have a direct impact about the way it simulates. So here we go. You can set up a wind. You can see that edge is right there as openings. All right, so we'll create the tensor structure. Think about sometimes if you want to open up some pieces, you do want to think about the consequence in terms of the overall behavior. So here I'm going to change it to a rubber again. See, that's the form looks like now. The last thing, let's talk quickly about the collision. This is not exactly necessary, I think, in the tensor structure case, but let's create a sphere. That's better. You could definitely set up objects as a collision objects in nuclear. This is very flexible. Basically, you can see this type is create given objects and unclass create a relation as a collision. So now if I select, it's better to do this in Outliner. Select both the sphere as well as unclass, then I can click this guy. So now we have a relationship. If I play the animation, you should see this kind of ten structure will being interacted with the sphere. It's a pretty nice way. If you do think, there are several kind of like a bubble diagram. You have several space you want to kind of enclose by this tensor structure. Yeah, possibly you can just run each of them as a collision objects. So now we have this form being interact with both spheres. You can also animate the sphere to see the final effects. All right, so that's a collision. The last thing I do want to cover super quick is about the patterning of the surface does affect the behavior, better or worse. Let's see here, if I give the same 10 by 10, if I do, for example, change the pattern, let's do a little bit random. Let's do a cut. Cut that way. So let's go to cut again. Let's change the okay, I guess that's fine. Let's just use the chamfer as a quick way. So if I do select a small piece of this surface and then do a chamfer, so basically I changed the kind of pattern across the surface, and I want to probably change the width to 0.3, 4. All right, so that's a chamfer. So I was wondering if this kind of affect the unclass simulation because the uneven patterns. So again, we are going to delete the history. We are going to freeze the transformation, and we are going to convert this to unclass. Okay, and then we can set up. I will just move it using the vertex. Do the pinpoint, and then we can run the simulation. It's hard to tell if there's any different behavior in this surface. Let's increase the gravity and let's change the material to rubber. Okay, and let's increase the gravity. So it seems like it doesn't really that significant. It does drift a little bit more in this part compared with this part. So I think it does affect, right? This part has more points than the other. So I guess the answer now is yes, the pattern does affect how the simulation will behave. And also I think this is something related with the, when you have an enclosed, it should have like a spring system between the collision nodes. I think that might be something you can take a look at later. If I display these stretch links in a new pattern, the stretch link is kind of being tweaked in a very interesting way. I think this will definitely affect the simulation for sure. Okay. All right, so I will turn this off. I think that will end this video tutorial.